Greetings. Today we're going to talk about gravitational potential energy. The equation for this is GPE equals mgh, which can sometimes you've seen kind of remember it a little bit better. GPE equals mgh. The mass is in the kilograms. G is acceleration to gravity. 9.8 meters per second squared. That's how fast we fall. Now the height has got to be in meters. And we're going to do some problems out of the Holt Science Spectrum book, page 299. We're going to calculate GPE for the car of mass 1,200 kilograms on top of a 42-meter hill. So I usually like to start with a little car as it's driving along, put some wheels on this, and it's sitting on the top of a hill. Okay, so that gives us a clear picture of what we have. And the next step is mass. What is the mass? We were given 1,200 kilograms. Now the next step is the height. What do we have? We have 42 meters. In both these cases, 1, 2 sig figs, 1, 2 sig figs. So just make a note in here that we have 2 sig figs that we're going to use with at the end. So now that we have 2 significant figures, we also know that acceleration due to gravity here on Earth is equal to 9.8 meters per second squared. So we're given these, plus, we also happen to know an equation. We know that gravitational potential energy is equal to mgh. And we also know that the units of this is joules equals kilograms meter squared per second squared is our final units that we'll need to end up with. So what is it when you want to find? So find what? We want to find gravitational potential energy. All right, so we got the equation equals mgh. Our next step is to go ahead and make sure we have the correct units. GPE is in joules down here. We have mass is in kilograms. G is in meters squared per second squared, so that'll give us some correct values here. And then the height is in meters. So everything is in sync as far as units goes. The first thing we check. So our next step is to plug in. So GPE is equal to the mass of 1,200 kilograms times gravity, 9.8 meters per second squared, that's acceleration due to gravity, times 42 meters. Okay, so this is the equation. So usually we start off with an equation, or what we want to find. What's the equation? This is called the plug-in, PI. And the next step is going to be solving. So let's group the numbers together. So we want to group like terms together. So we have 1,200 as a measure times 9.8 times 42. And then we can put all the units together. Kilograms, meters times meters divided by seconds squared. This we recognize as a joule since we have the equation right over here. Okay, so our next step is to multiply this out on a calculator, and we end up with 49,3920. 493,920 joules. That's too many digits. We need to reduce this down. So let's round up. What do we have? Remember, we have 2 significant figures, so we're allowed 2. Because we're going to just round to 490,000 joules as an answer. And again, we don't like looking at all these zeros. So let's put that into scientific notation. So that's 4.9 times 10 to the 1, 2, 3, 4, 5 places, 10 to the 5th joules as a final answer. In our second problem, we have a climber who's on Mount Everest, and we want to calculate his gravitational potential energy, and Mount Everest just happens to be 8,800 meters tall. So here, the first thing we're going to do is draw this little picture of this mountaintop, and so we have this climber up here, and we want to know if they drop all the way down to the bottom, what is their energy up there compared to the bottom of the hill. So we were given that we have a height is equal to 8800 meters, and since it's in meters already, we don't need to translate it. And we know we have a mass, and that is 65 kilograms. We know that the acceleration due to gravity on Earth, maybe sometimes put a little E down there to kind of remember that we're on Earth, and this is 9.8 meters per second squared. So we've got all these values, and what is it we want to find? So find GPE, gravitational potential energy. Okay, so the first thing is, what's the equation? GPE equals mgh. And so our next step is to go ahead and now you can plug in, since we have all the correct units. We have kilograms, we have meters per second squared, we've got meters, everything's in the scientific units that we want. So GPE is equal to 65 kilograms times G, 9.8 meters per second squared, times the height, which is 8,800 meters. So our next step is to go ahead and put these numbers together. That's 65 times 9.8 times 8,800, and let's put all the units together. Kilograms, meters second squared, meters. So kilograms, meters times meters divided by seconds squared. Oh, so we have kilograms meters squared per second squared, and we already know from the prior problem that that is equal to a joule. And these numbers give us a total of 5,605,600 joules. That's too many digits. After all, we're only allowed 1, 2, 1, 2, 1, 2. Two significant digits in all our inputs. So we have 2 sig figs to start, which means in our answer down at the bottom here, we're only going to be allowed 2 sig figs down here at the very end. So let's round. Rounding goes to 5,600,000, and if we keep the commas in the same place, we can see still have 5,600,000 joules. And again, so many zeros. So let's make sure that we understand that this is 5.6, 2 significant digits, times 10 to the 1, 2, 3, 4, 5, 6 places, 10 to the 6th joules as a final answer. Okay, in problem 3, we are given that a student is holding a 55-gram egg. It's outside a window, so we're doing a drop test as part of the little experiment to see who can have the egg that does not break upon dropping. And we know from prior calculations that it's got 8.0 joules gravitational potential energy. Of course, we got to kind of make it a little bit of a challenge, not too far up, not too far down, so most eggs will kind of get smashed up even if they're protected, but if we're good, maybe some will not. So we have to find the right height. So what is the fall distance is what we want to calculate for this little contest that we've put together. Okay, so I usually like to draw a little window out here. There's someone's got a hand sticking out and they're holding on to an egg. So they've got their thumb and their hand, they've got their fingers on the other side. So we have a hand with it that's just about to drop it down to the ground. And we're going to find this height of how far up do we need to be. Second story, third story, fourth story, how high do we need to be? Okay, so let's review this. We have a mass is equal to 55 grams. We have a gravitational potential energy, and that's going to equal 8.0 joules. And we know that acceleration due to gravity here on Earth is equal to 9.8 meters per second squared acceleration. Well, one thing we notice, 55 grams, that's not quite the right unit that we want, so we need to convert it over. So 55 grams times, and we need a conversion factor. We want it in kilograms, so that has to go on top. And we need to cancel the grams. Grams goes down below. And for every 1 kilogram means that there is 1,000 grams. So now we can cancel the grams, and 55 divided by 1,000 is 0.055 kilograms. So now we have an SI unit that we can use in the equation because it's in kilograms. So what is it we want to find? Okay, we want to find height. Height, we'll call that h. And, well, what equation do we have to start with? Equation, we know that GPE equals mgh. Okay, that's good. But this doesn't solve for h, this solves for GPE. So to solve for h, we kind of have to change the equation. Let's divide both sides by mg. Divide by mg, divide by mg, so that mg cancels, and this is equal to h. Now we have a solution for height. So GPE divided by mg. Okay, so now we have height is equal to GPE. Let's just rewrite that. Always keep things in order. Divided by mg is equal to GPE, and we have it in joules, 8.0 joules, divided by mass, which was over here. You have to come down to the kilograms one, got to remember, and that's 0.055 kilograms. And G, can extend this out, so times G, 9.8 meters per second squared. So now let's start combining things together. Now we're going to combine the numbers together and the units together. So we end up with 8.0 divided by 0.055 times 9.8. Sure, it's extended out. And everything's still multiplication, even though it's units. We treat them just like numbers. Times joules. And joules, oh, that doesn't quite cancel with anything. So right here, we've got to translate the joules. So what is a joule equal to? Joules equals kilograms, meters squared per second squared. So let's change that over. So let's put kilograms, meters squared per second squared. That goes on the top. And down below we have kilograms, meters per second squared. Okay, so can we start canceling? Yes. So kilograms cancels. That's pretty easy. Second squared, same spot. We can cancel those. We've got, a squared term on m up here and a single m down here. So let's just take out one of the m's. And we're left with a single m on top. So now we have, let's go through the numbers, and this adds up to, or in a calculator, ends up being 14.84423 as the calculated number, and we end up with meters, so that's what we want. But this is way too many digits. Remember, we only have 2 sig figs, 1, 2, 1, 2, 1, 2. So with 2 sig figs, we've got to round it off. So get rid of all the excess at the end, and that 8 is going to be rounding up that to 15 meters, and that is not needed to be changed over in scientific notation. It's very clear. We have 2 digits in our answer, so we just simply keep it like this and not change it to scientific notation. And there we have our 3 problems for today. Thank you for joining us.